Your building is like some of the buildings here, it's up and down. It's a friendly building. It relates to other buildings on the campus, which is, a surprise. Other buildings on the campus smashed together are collaged without thought. And in a way, your building takes the grammars that are around and does the collisions with terrific finesse and poetry. And I wonder if you could just talk about this crazy and very familiar geometry you've made.
I tried to create a building that, first of all, is not an institution. It's a home for people who will spend a long time. So I thought a lot about the beauty of, you mentioned a cathedral. How do you make something which is interesting, which will inspire people to think that's their job, and at the same time pick up ideas that don't necessarily come just from the functional programming. You have to put many offices. It's a very dense building. So I used really the development of the Fibonacci series and the spiral. It's a 10-sided figure which is turned and torqued around the center, which is the skylight and the atrium. And the interlock gives variety of dimensions between there's 3-floor building. So it creates many unexpected encounters for people who want to go out on a terrace, who want to go out to a garden, who want to have an office which is not perfectly orthogonal, and so on. So it's a combination of my love of architecture and my huge awe for the people who are working here.
So the Fibonacci series goes 1, 1, 2, 3, 5, 8, 13. It's a very interesting set of getting bigger and bigger and bigger. Corbusier used it a lot. It's been in history of architecture since the early Greeks or before. And it's supposed to be beautiful in itself, but how you've used it is so different because as I understand it, it's based on a spiral galaxy. The inspiration.
It is.
Is that right?
It's correct. It's on the spiral galaxy. And it's not only within the building, but it really goes to the cathedral. Its origin is the cathedral, then it makes its way to the building, and the building does a microcosmic turn within it. And of course, it's adjusted to a lot of chaotic forces brought in by the program, by necessities, by materials, by weight, by gravity. But it is a kind of a picture of that beautiful cosmic...
Could anybody decode it if they sat down with the actual drawings, the construction drawings, and find and locate the points?
I don't say that it would be easy job, because some of the corners would maybe not fall on any obvious corner, but they would be in there as a guiding motif of the project. I don't think the project is a direct linear extrusion of the spiral.
But so you were then opportunistic about saying, well, okay, I want these geometries, I need these functions, and I'm going to pick up points where I need and want them.
And I can violate them, and that's true, and they can be violated by the landscape.
So it wasn't a rule that squeezed you too hard, but it was a rule that you would allow, like a musician, to improvise with? Or?
Well, it's true. It's an interpretation. I mean, look, you mentioned the grand history of Fibonacci, but so many people have used it in non-obvious ways. I mean, when Le Corbusier put it on top of a building and drew it in the Gaika's books, I have seen also, imposed on faces, on vases. It's not completely convincing, because some of it is just a forced geometric game.
That's always the case with architects. There's choice with these points, and that's why the proportions always change.
It's an extremely disciplined building. First of all, discipline is how do you make a very compact plan that allows for the economy of the building. You have to have offices getting all light, all on the perimeter. You have to have the necessary technologies everywhere. So it's basically a very, very known typology, but how then do you make it interesting? How do you create the unexpected without grand gestures?
It reminds me of a wonderful piece of Noguchi's ambiguous art, where it's the expectation of 4 figures, but there are actually 5.
Yeah.
And you can never figure it out as you walk around his work of art. It's in Long Island.
It's true. And where is that figure? Yes.
Yeah. And so when I walk around the building, I keep thinking I understand it as 2 buildings, like this.
But they're not.
But they're not.
No, they're not.
So I want to ask you, this is a question for architectural historians, all right? So famously in 1966, Robert Venturi wrote a book, Complexity and Contradiction in Architecture. And ever since then, architects have been able to talk about complexity and contradiction. Now, when I look at this building, one of the strangest and most interesting things is the way everything seems to be tilted and colliding and smashing through each other. But actually, when you get inside, it's all flat floors. Mm-hmm. And I keep saying, who done it? It's a mystery, and I want to know who did it. How do you get everything that's tilted to be flat?
But you know, it's all functional as well, because we have necessary barriers for sound from the noise of the street. We have necessary topographies. The site is very, very, it's not a flat site, far from it. So I'm using these tilts, these junctions, to really shape the space of the building.
As Durham Cathedral does, by the way. Now, it's contradictions between, you have glass and black steel, I guess it is, yes. And then you have this amazing slatted wood, which to me looks red, but I know it's going white in a bare hair. Okay. It's going to, it'll age like us. Those are contradictions in material, and they're really nice contradictions because it's warm and friendly and understated. Of all your buildings, I must say, this one, in a way, is the most contextual.
One of my challenges to myself was, how does this building fit in? And I'm not usually thinking that. If you have a context, I always am tending to challenge the context. Yeah. But particularly university kind of where people are studying, they're scholars, I didn't want a building that looks like it's not really part of this thing. It's something else. It's elitist. I want to make a building which is very, very open, and it is open to the public. People can enter the first floor, participate in the seminars. So I've tried to use that kind of vernacular, but in a way which is a little bit different.
It is different. It's definitely different. It's a very friendly space. It breaks people up into small little breakout rooms. Yeah. Has one problem. And the problem is acoustics, because they had to cut out, because of cost, they had to cut down on the acoustics. They had a lot more acoustic baffling here.
Of course, there are always technical issues in a building, but I think books, materials,
how you furnish it,
and people will furnish it because it's a home.
Our relationship has a long history, but it goes
longer than you even know. Because I, as a student, read your brilliant book called Meaning in Architecture. I think it was you who introduced the term into architecture. And it was the first book I saw. Somebody isn't just talking about some stupid thing. Somebody's actually talking about meaning. And I think that was really, I just have to tell you, that was a big,
I didn't know that.
Huge impact on my thinking at that time when I just went to school. Thank you.